welcome to Module 1, Cloud Concept Overview. Let's begin. For this module, we have 4 sections. The first section we have is Introduction to Cloud Computing. The second one is Advantages of Cloud Computing. The third is Introduction to Amazon Web Services. And the last section we have is AWS Cloud Adoption Framework, or the CAF. After completing this module, you should be able to define different types of cloud computing models, describe 6 advantages of cloud computing, recognize the main AWS services categories and core services, and the last, review the AWS Cloud Adoption Framework. Let's go to the section 1. We have Introduction to Cloud Computing. What is cloud computing? By AWS, cloud computing is the on-demand delivery of compute power, database, storage, applications, and other IT resources via the internet with pay-as-you-go pricing. These resources can run on a server computers that are located in large data centers in different locations around the world. Meaning, when you use a cloud service provider like AWS, that service provider owns the computers that you are using. These resources can be used together like building blocks to build solutions that help meet business goals and satisfy technology requirements. Cloud computing also enables you to stop thinking of your infrastructure as hardware and instead think of it as a software. Let's take a look at the traditional computing model. In the traditional computing model, infrastructure is thought as a hardware, meaning hardware solutions are physical, which means they require space, staff, physical security, planning, and capital expenditure. In addition to significant upfront investment, another prohibitive aspect of traditional computing is the long hardware procurement cycle that involves acquiring, provisioning, and maintaining on-premises infrastructure. With the hardware solution, you must ask if there is enough resource capacity or sufficient storage to meet your needs, and you provision capacity by guessing theoretically maximum peaks. If you don't meet your projected maximum peak, then you pay for expensive resources that you stay idle. If you need or exceed your projected maximum peak, then you don't have sufficient capacity to meet your needs. And if your needs change, then you must spend the time, effort, and money required to implement a new solution. For example, if you wanted to provision a new website, you would need to buy the hardware, rack and stack it, put in a data center, and then manage it or have someone else manage it. This approach is expensive and time consuming. By contrast, cloud computing enables you to think of your infrastructure as a software. Software solutions are flexible. You can select the cloud services that best matches your needs, provisions, and terminates those resources on demand and pay for what you use. You can elastically scale resources up and down in an automated fashion. With the cloud computing, you can treat resources as a temporary and disposable. The flexibility that cloud computing offers enables businesses to implement new solutions quickly and with low upfront costs. Compared to hardware solutions, software solutions can change much more quickly, easily, and cost effectively. Cloud computing helps developers and IT departments avoid undifferentiated work like procurement, maintenance, and capacity planning, thus enabling them to focus on what matters the most. As cloud computing has grown in popularity, several different service models and Deployment strategies have emerged to help meet the specific needs of different users. Each type of cloud services model and deployment strategy provides you with a different level of control, flexibility, and management. Understanding the differences between these cloud service models and deployment strategies can help you to decide what set of services is right for your needs. Let's take a look at the cloud service models. So there are three main cloud service models. Each model represents a different parts of the cloud computing stack and gives you a different level of control over your IT resources. So on the premises, we have applications, data, runtime, middleware, OS, virtualization, servers, and storage and networking. So these are managed by you. And next we have the infrastructure as a service, or the IaaS. So infrastructure as a service is the services in this category are the basic building block for cloud IT and typically provides you with the access to networking features, computers like virtual or dedicated hardware, and data storage space. So IaaS provides you the highest level of flexibility and management control over your IT resources. It is the most similar to um, existing IT resources that many IT departments and developers are familiar with today. So as you can see from middleware, I mean operating system, these are all managed by you, and starting virtualization up to networking, these are managed by others, meaning the service provider or the cloud service provider like AWS. So next, for the cloud service models, we have the platform as a service, or the PaaS. So services in this category reduce the need for you to manage the underlying infrastructure. Usually these are the hardware and operating systems, and enable you to focus on the deployment and management of your applications. So as we go along, from runtime up to networking, these are already managed by cloud cloud service provider like AWS, and you only manage by I mean you only manage applications and data with the platform as a service. Next, with the last cloud service models, we have the software as a service, or the SaaS. So these services in this category provides you with the completed product that the service provider runs and manages. In most cases, software as a service refers to the end user applications, with a SaaS offering you do not have to think about how the service is maintained or how the underlying infrastructure is managed. So you need to think only about how you plan to use the particular piece of that software. A common example of SaaS is application is a web-based email where you can send and receive email without managing features, additions to the email product, or maintaining the servers and operating systems that the email programs runs on. So with the SaaS, these are already managed by the cloud service providers like AWS. There are three main cloud computing deployment models, which represents the cloud environments that your applications can be deployed in. So the first one, we have the cloud. The second one is the private cloud, or the on-premises. And the third one is the hybrid combination of the cloud and the private cloud. On the cloud, a cloud-based applications is a fully deployed in the cloud, and all parts of the applications run in the cloud, meaning the applications in the cloud have either been created in the cloud or have been migrated from an existing infrastructure to take advantage of the benefits of the cloud computing. Cloud-based applications can be built on low-level infrastructure pieces, or they can use higher-level services that provides an abstraction from the management, architecting, and scaling requirements of the core infrastructure. On-premises or the private cloud is a deploying resources on premises using the virtualization and resources management tools. It's sometimes called the private cloud. While on the on-premises deployment does not provide many of the benefit of cloud computing, it is sometimes sought for its ability to provide dedicated resources. In most cases, this deployment model is the same as the legacy IT infrastructure, but it might also use application management and virtualizations technologies to increase resources utilization. And lastly, we have, I mean, the hybrid, the combination of the cloud or the public cloud and the on-premises, the private cloud. A hybrid deployment is a way to connect infrastructure and applications between cloud-based resources and existing resources that are not located in the cloud. The most common method of hybrid deployment is between the cloud and an existing on-premises infrastructure. This model enables an organization to extend and grow their infrastructure into the cloud while connecting cloud resources to the internal systems. Next, we have the traditional infrastructure in AWS. So, for this part, there are similarities between these traditional infrastructure in the AWS space. AWS security groups, network ACLs or the ACLs, and AWS IAM are similar to the firewalls, access control lists, and administrators on the traditional infrastructure of the security. Next, we have the in networking. In networking in the cloud, we have the elastic load balancing, and the Amazon VPC or the virtual private cloud are similar to routers, network pipelines, and the switches in the traditional infrastructure. Next, we have the servers. AMI or the Amazon Machine Images and Amazon EC2 or the Elastic Compute Cloud instances are similar to on-premises servers. So Amazon EC2 is the virtual servers in the cloud. Next, on the storage and databases, we have the Amazon EBS or the Elastic Block Store, Amazon File System or the EFS, Amazon Simple Storage Service or the Amazon S3, and lastly, the Amazon RDS or the Relational Databases Service are similar to Direct Attached Storage or the DAS, Storage Area Networks or the SAN, Network Attached Storage NAS, and lastly we have the Relational Database Management Service or the RDBMS. So these from the traditional infrastructure, there are similar technology have already been deployed in the cloud or AWS cloud. Some key takeaways from this section of the module include: cloud computing is the on-demand delivery of IT resources via the internet with pay-as-you-go pricing. Cloud computing enables you to think of your infrastructure as a software. There are three cloud service models. We have the infrastructure as a service or the IaaS, platform as a service or the PaaS, and lastly we have the SaaS or the software as a service. There are three cloud deployment models. We have the cloud, hybrid, and the on-premises or the private cloud. There are there are many AWS service analogs for the traditional on-premise IT space. Almost anything you can implement with traditional IT can also be implemented as an AWS cloud computing service. Get ready for the section 2. We have the advantages of cloud computing. See you there. Thank you.